Yes, hello dear students. Welcome to class 10th. I shall be taking your physics here. And before starting this physics, first of all, accept my heartiest congratulations on coming to class 10th. Because of your hard work, you are now in class 10th, and I am sure that this hard work will continue in class 10th also. Right? So the chapter which we are going to discuss in class 10th in physics is electricity. Electricity. So first of all, what is the importance of this electricity in our life? How important it is, this you know, but even then we shall like to discuss this, right? And after that, what constitute this electricity and how does it flow in an electric circuit, and what are the factors on which electricity depend, right? And after that, what are the other uses of electricity in our daily life here at home, we shall like to discuss. Now, in these activities, what we saw, paper is being attracted. It is changing its position. This means comb is possessing some energy. Work is being done on the paper plates. Here, repulsion is there. So change in here you can see distance is increasing. Work is being done. This means energy is there, which is pushing it away. Here, this is attracting it. It is attracting it. Means it has some energy. Therefore, it is pulling it towards it. Now, what do we say that energy possessed by flowing charges is is known as electricity. Here, some activities, these two activities we can see here. In this activity, we can see, so just I have taken these straws from fruity, which you use, which you drink, which you enjoy. So I taken these two straws of fruity. Now you can see what is happening. This one, these two, these two were rubbed with dry hair, and now what is happening here? Repulsion is taking place. You can see. Repulsion is taking place.
Both have got same charge, therefore repulsion is taking place because of repulsion moving away from this. Here we can say that like charges repel each other.
Right. So here moving away. So here this means moving away means both are having both are having similar charges. Charges you have been taught in class 6. Even then we shall be discussing. So therefore straight away I am saying that these two are charged and that too similar charge. Similarly charged. So therefore that second one is moving away. Now in this activity I have taken this again straw, which is first I rub with dry hair, and this is the bottle, and from which water is coming out, okay, in thin stream. Here you can see what happens when it is brought near this water stream. Then you can see here it is changing its position, right? So it is water, it is being attracted by this straw. So this shows that this charged straw, it contains energy. So now, what is charge? Question comes to us that what is charge, right? So before going for that, energy possessed by flowing charges, simply we say that it is electricity. Energy possessed by flowing charges is known as electricity. But here these charges are not flowing here. Here charges are not flowing here. These charges are at rest. We are going to discuss in our next topic. Now, electricity, it is of two type here. We were talking about we have taken some examples here. So here these were the example of static electricity. Electricity. So electricity is divided into two parts. It is of two types: static and current. Static means stationary. Static means stationary. Station is fixed. A station is fixed place. The same way from station, this word is there, static electricity. It is a study of charges at rest and their interaction. At rest means, what does it mean that at rest? So when we rub a comb with dry hair, then what happens? So this comb gets charged. So these charges are at rest. They are not continuously flowing in comb. Why? Because comb is an insulator. They can't flow in it continuously. So therefore they come to rest, and they are there on the comb for some time. And as long as they are there, paper bits are attracted. Now, now, now static, and we know that about the charges. These are of two types here, which we are going to study. So electric charge. What is a charge? So charge is a physical property of matter or substance which causes it to experience a force on keeping it near other matter or substance. So when a charged body, means when we bring this comb, when it is rubbed with dry hair, so when it is brought near paper bits, what happens? So it causes now it to experience a force. So then this comb, it apply force on paper bits, and therefore these are attracted, right? So electric charge is a physical property, again matter or substance, which causes it to experience a force. And this force can be force of attraction or force of repulsion. In the case of straw, when I took two straws, then what you see, that these two are repelling each other. So from this, what do we come? And in second case, in case of water, this water, when I was bringing straw near water stream, it was being attracted. So from this means, what do we come to now? Their force of repulsion and attraction. Force of attraction or repulsion. Both forces are experienced right here. So from this, we come to know that there are two types of charges, positive charge and negative charge. So when these charges are at rest, the study of charge at rest is known as static. And when these charges are in continuous motion, then it is called electricity. So means study of charges in motion in a conductor. Here it is conductor. Conductor word is important here. Metals are conductors. Okay, this aluminum, copper. But when we talk about the scale, plastic, glass rod, these are not conductors. Therefore, charges in them do not flow continuously. They are at rest. So current means flow. Current word, its meaning is flow. Right? So charges are of two types. Now we are going to just study about the force. On what factor this force of attraction or repulsion depend when these two charges are brought in contact of each other, near each other, or they are kept at some distance from each other, or when they are opposite in nature. So from experiment it has been observed that this Q1 and Q2, Q1 is positive charge, Q2 is also positive charge. This we know that like charges repel each other. This you were taught in class 6th or 7th also. Again we shall be studying here, right? So when they are away from, when the distance between their centers, from here we take the distance, from here at the center, from center we take the distance. So from experiments it has been observed, this force of attraction, it depends upon the two factors. Number one, the quantity of charge Q1, quantity of charge, another charge Q2. So it is directly proportional, means if the product of these two charges is higher, the force of attraction will also be higher, directly proportional. Greater is the charge on two, more will be the force. And from experiment it has been found that if the distance between their centers is increased, okay, then this force of attraction it is decreased, inversely proportional. If this R increases, F decreases. So here same case, here opposite charges are there, they will attract. Here similar charges repel, and here this attract. So this force of attraction repulsion is directly proportional to product of their charges and inversely proportional to the square of the distance between their centers, right? And formula from this we come to know of this force of attraction repulsion is equal to K Q1 Q2 upon R square, where K is the constant of proportionality and its value has been found 9 into 10 raised to 9 Newton into meter square upon Coulomb square. So how can we get this K? So F into R square. F into R, F is N into R square. R means meter, distance is in meter square, q1 q2 coulomb, so upon coulomb square. So this way we get unit of this constant of proportionality, right? So now it is known as Coulomb's law. It is known as Coulomb's law. It states that magnitude of electric force between two point charges is directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance between their centers. Between their center I am not written, but you can write down. Okay, you have to. It's not written generally in definition. Between them and acts along the straight line joining the two charges. The straight line, it acts along straight line, right? So definition of 1 coulomb. 1 coulomb is that charge which exerts a force of 9 into 10 raised to 9 Newton. Newton is a unit of force on equal charges. Equal means Q1 and Q2 is equal to 1 coulomb. Then only you will be getting 1. 1 into 1 is equal to 1 at a distance of 1 meter. When we take Q1 is equal to Q2 1, and then R is also 1, then force F is equal to K, and we get the value of this force. Force is equal to this much Newton, right? Now next, what are the properties of charges, right? So these are some properties of charges: attraction and repulsion. We have discussed earlier, similar charges repel each other and opposite charges attract each other. Unlike mass, the electric charge on an object is not affected by the motion of the object. The mass, when charge is moving from means a body is being attracted by another body, or charge is transferred. So unlike mass, the electric charge on an object is not affected, right? As mass remains same, only weight is changed when a body is changing its place. You know, weight is equal to m into g, and g is changed, therefore weight is changed, mass remains same. Same way, electric charge on an object is not affected by the motion of the object. Electric charge can be added arithmetically. Simple arithmetic using it we can add. Electric charge is conserved. It also can neither be created nor be destroyed. Only transfer. It can be transferred from one body to another. Here next is electric charge is quantized. What does it mean here? Quantized means Q is equal to plus minus n into E. Here this means plus for proton, this minus is for electron. N is the number. N is the number which is greater than 0. It can be 1, 2, 3, 4, 5, right? Any number. E is the charge on an electron. If we talk about the electron, then it will be minus 1.6 into 10 raised to minus 19 coulomb. And N is any integer, positive or negative, not 0. Positive or negative. Negative in case of electrons, positive in case of protons. So quantization of charge means total electric charge present on a body or substance is an integral multiple of elementary charges. Means it can be multiple or twice of this, thrice of this, 5 times of this. Okay, is known as quantization of charge, right? Electric charge present on a body, again I am repeating, substance or substance in an integral multiple of elementary charge. This elementary charge E. Value of E is this. So charge present on a body will be the multiple of this charge. Is always multiple of this charge. Means plus for K proton, minus for electron. 1.6 into 10 raised to minus 19 coulomb.
See. Now first topic is this: how charge is produced. Just I discussed that when plastic scale is rubbed with the dry hair, it gets charged. So how is charge produced? Charge is produced through the transfer of elementary particles known as electrons. So on rubbing, what happens? These electrons are transferred from one body to another body. So because we know that an atom, it is made up of three fundamental particles: neutrons, protons and electrons. But out of these three, electrons can be transferred from one atom to another atom, from one body to another body. So therefore it is a transfer of electrons. Charge is represented by Q, and it is equal to plus minus, here sign is there, N into E. Why plus and minus? Because plus if it is proton, negative for electron. N is the number, how many electrons are being transferred out. Now E is the charge. The magnitude of charge on one electron, it is minus 1.6 into 10 raised to the power minus 19 coulomb. So here this minus shows that it is for electron, charge on electron, and for proton it is positive. Charge on n electrons will be then minus n into E, or n into this 1.6 into 10 raised to the power 19. E is the charge. How many charges are there? And if two number charges are there, then 2 into 1.6, 3 into 1.6. N is the number of electrons, just I explained, and n can never be in fraction. It is a whole number. It is a complete number. It can be 1, 2, 3, 4, 5, any number. And a substance can have two type of charges. Positive charge, it has a deficiency of electron. If a body is having deficiency of electrons, then it is said to be positive charge. Then protons are more on that body. Protons are positively charged, so therefore protons are more in number, so therefore that body is said to be positively charged. A negative charge, it has an excess of electron. So when a body is having negative charge, so we say that it has excess of electrons. This means it has taken electrons from another body. So therefore it has excess of electrons. So electrons are more than positive particles, protons. So it is said to be negatively charged body. Now after this, what happens what happens when these charges are at rest or are flowing? So electricity, actually this is of two types: electric current, static, and current. Electric current. So we are going to study about the electric current. Current means flow, flowing. Current means motion. So electric current we are going to study, but not about the static electricity. We are going to study current electricity. So electric current is a time rate of flow of electric charges through a conductor. Conductor is very, very important. Conductor, it cannot pass through insulators. Okay, so therefore conductor. What is important here? When a potential difference is applied between its and is okay. Now electric current, how do we represent it here in the form of formula? It is the charges, total charge upon time, because it is time rate. Time rate means numerator and denominator. So numerator upon denominator. How do we represent? What is a unit of electric current? This question comes to our mind. So SI unit of electric current is ampere. SI unit is ampere. It is represented by capital A. It has been named after Andre Marie Ampere, who discovered it. So to just give honor to him, it has been named after him. 1 coulomb of charge, it is equal to 1 ampere charge is equal to 1 coulomb upon 1 second. Now current flows from higher potential to lower potential. We shall be studying in second session about potential. It can flow in, it cannot flow in absence of potential difference. If you are using a dead cell with zero potential, then and you are using it, electric current will never flow through the conductor. Electric potential is a cause, and electric current is an effect of potential difference. If potential difference is there, only then electric current will flow. In absence of a battery or a cell, electric current cannot flow through a conductor. Now again, in electric current, what is the definition of 1 ampere? How will you define 1 ampere? 1 ampere is a current when 1 coulomb charge flows through a cross-sectional area of a conductor in 1 second. Cross-sectional area. So here this portion is showing cross-section. How many electrons are passing through this in 1 second? So this is representing here cross-sectional. From this given area, how many electrons are passing through? And these are smaller units: milliampere 10 raised to minus 3, micro 10 raised to minus 6A. Electric current in terms of number of electrons. So before this we studied about I is equal to Q upon T, charge upon time. Here Q is equal to N into E. This we have done in earlier slides. So total charge passing through a cross-sectional area is equal to N into E. Right. Now electric current is a scalar quantity because on changing its direction, its strength is not changed. In class 9th you have done when two forces are acting on a body in different directions, then what happens? So on changing the direction of electric current, its magnitude is not changed, so therefore it is a scalar quantity. Now this is one example how to solve numerical. Calculate the number of electrons present in electrons present in 1 coulomb. So here given, it is must. First of all, you should write given, then to find, I have not mentioned here, and then solution. 1 coulomb charge is here, charge on 1 electron is this. We know, since we know that, we should write in numericals or in some answers also. Q is equal to NE. Using this, here we can solve. Here what I have done, 10 raised to power minus 19. 19 directly it has been taken to denominator. Simple mathematics. Mathematics is very, very important. Here 10 upon 16 I have done, because point has been removed, it becomes 10. I am taking 1 0 from this side to this, and it becomes 100. So 100 upon 16 into 10 raised to 18, it becomes 6.25 10 raised to power 18. Now these are some numericals. I'm sure you will be doing practice, and in board exam you will be getting one numerical. Okay. Now, how electric current is measured? This question is generally asked. Okay, and you should know how do we measure electric current. To measure electric current passing through a circuit, passing through a conductor, we use a device known as ammeter. A for ammeter and A for ampere. So simply, it is very easy to remember. A for ampere, A for ammeter means this device is used to measure amperes, means strength of current passing through a conductor. A meter of minimum least count measures current more accurately, because if least count is minimum, you know what is least count, I shall be discussing in next topic also. So least count, minimum, how much current is passing, minimum current it should measure, therefore it should have least count. Precaution should be taken while using ammeter. It should never be used in parallel in electric circuits, because a good ammeter has low resistance. So when large amount of current will pass through it, and when it is in parallel, we shall be studying in electric circuits, then high amount of current will damage the ammeter. Now it is connected in series in electric circuits always, because it has to measure the total current passing through the conductor. The plus is of ammeter should be connected to plus of cell or battery. Positive, plus means positive. Negative of it should be connected to negative of cell or battery which we are using. And characteristics, again, it should have low resistance, we have discussed. To allow large amount of current, if it has low resistance, the resist means to oppose. It will not give opposition to the flow of electrons, so it will measure current passing the conductor very accurately. And an ideal ammeter should have zero resistance. When zero resistance there, then it will allow whole of the current which is being given to the circuit. Now, least count of ammeter, and here it is a minimum value of electric current measured by an ammeter, minimum, smallest. So if here you can see from 1 to 2, 0 to 2, if 20 divisions are there, then what will be the least count? So 2 upon 20, then it will be 2 upon 20 means 1 upon 10 is equal to 0.1. Now range of ammeter here in this is the second case. Here you can see it is 0, and if we come to 50, its range is 0 to 50, means it can measure up to 50 ampere of current. And here this ammeter, it can measure 0 to 10 ampere of current. Got it? Now least count formula, least count is equal to range of ammeter. Here E is missing here. Total number of divisions. So here in second case, here 50 is total is 0 to 50 upon 50 divisions are there. Therefore it comes out to be 1 ampere. We can find by using this method also 0 to 10. 0 to 10, range is 0 to 10, so 10 minus 0, and here 10 is divided by how many divisions are there? 10. Here red mark is showing, this red line is showing 5. So total 10 divisions, 10 upon 10 is equal to 1 ampere. It's very, very easy. Ammeter is used in labs also. When you will be doing experiment, you will be using it. So a reading of ammeter, what will be the reading of ammeter here? Needle is here. So this number of division into least count. Number of divisions are how many? 9 divisions are. It is on 9th division. Least count is 1. So therefore it will be 9 into 1 ampere. Now this was for first session, and in second session we shall be talking about the potential difference, voltmeter, and then Ohm's law. So till now, thank you, and I'm sure you must have enjoyed, and do revise at home. God bless you.